HVAC stands for heating, ventilating, and air conditioning. HVAC systems generally include the following basic components: a heat generating system, a cooling system, an air handling and filtration system, and a control system for operations. The HVAC system is meant to provide complete conditioning of the air, which may include the filtering out of dust and odors, freshening with outside air, adjustments of the temperature, and adjustment of the relative humidity. The temperature can be modified anywhere in the building with the help of the BMS and also manually by the thermostats which are placed everywhere. Some factors that must be taken into account for HVAC systems are the space for equipment, the noise and vibration of the equipment, space for air duct systems, and the properties of the building enclosure. Proper space must be allocated for all this. HVAC equipment is generally very large and bulky. To be operationally feasible, the equipment must also be strategically located. The equipment must be accessible for maintenance and replacement purposes. Noise and vibration are other factors that must be considered during the design stage. This is critical for cooling equipment and large fans. HVAC systems require large spaces for air duct networks too. Ducts are used to serve the building interior spaces and link up with the operating equipment. The air intake and exhaust must connect to the outdoor air at appropriate locations. As discussed before, compartmentation is a very important aspect in hospitals. The HVAC system is a very critical service in a hospital. Its complication comes from the fact that a hospital is filled with people with infections. The HVAC system has to be so designed so that there is no cross-contamination from one to another, and it has to be avoided at all costs. We cannot afford to have cross-contamination through the HVAC system. This is done generally by creating compartmentation and use of filters and scrubbers. Compartmentation is done by many ways. First is physical separation. Then we can use water curtains, air curtains, and we also use a pressure difference to create that compartmentation. Each department in a hospital will have its own individual AHU, and this air is not mixed with any other air. Additionally, all critical areas also have their own individual electrical flow panels and their individual UPS. For HVAC in a hospital, chilled water system is perhaps the most efficient system, even though its initial cost may be high. As we can see in this image, the chilled water pipes from the chiller, they go to all the AHUs where heat exchange takes place and the air is conditioned. This conditioned air is supplied to the building via ducts. After the heat exchange, the water is sent up to the cooling towers for pre-cooling and then back to the chillers for final cooling. The various equipments that are used in the HVAC system are, first of all, a chiller. In a large hospital, we need high efficiency chillers. A chiller is a machine that removes heat from a liquid via a vapor compression or absorption refrigeration cycle. This liquid can then be circulated through a heat exchanger to cool air, which is then circulated through ducts throughout the hospital. The HVAC plant room is generally placed in the basement. Now there are the air handling units called the AHU. AHU is a device used to regulate and circulate the air as part of the HVAC system. An AHU is usually a large metal box containing a blower, heating and cooling elements, filter racks or chambers. It is very noisy and needs dampers and acoustic lining. As we can see in the attached diagram, AHUs supply conditioned air to every area of the hospital through ducts. Another set of ducts take return air from every area and return it to the AHU. This air is conditioned again and supplied. However, a small amount of fresh air or treated fresh air is mixed in it. Now, how much fresh air is to be induced or how many air changes per hour is different from regular buildings, and in hospitals it is designed as per ASHRAE 170. The air changes per hour is different for each type of area within a hospital also. An AHU should have access to fresh air either through an external wall or through an adjoining shaft. In a hospital, return air and fresh air needs to be filtered before conditioning and before supply. This is done by different types of filters placed mostly in the AHUs. AHUs may be placed on the service floors. Additionally, there may be some floors or ceiling mounted AHUs on every floor according to the area they are serving. In a hospital, all critical areas have an AHU of their own, so as not to mix the air with other areas. The next component of HVAC is cooling towers. Cooling towers use the evaporation of water to remove process heat and cool the working fluid from the return air. This slightly cooled water is then sent to the chiller to be thoroughly cooled. Cooling towers have to be placed in the open. The terrace is a commonly used location for cooling towers, even though they can also be placed outside in the setbacks, etc. A thermal wheel is an instrument through which a large percentage of heat can be recovered using ventilation and transferring it to incoming fresh air. Next we have is the fan coil units. A fan coil unit, also known as FCU, is a simple device consisting of a heating or cooling heat exchanger or coil and fan, as you can see in the picture. Ducts are used throughout the hospital. Now ducts are metallic tube-like elements which carry conditioned air and return air through an HVAC system. The cross section is designed to optimize the airflow. The duct sections vary through the network with varying amounts of air through them and its pressure. They may need thermal and acoustic insulation as well. So ducts, in this image that you see, you will see that ducts have not only varying diameters, but they also have special jointing so that air may not leak from there. Diffusers and grills are installed at the supply end of the duct to diffuse and supply the conditioned air. Many types of filters are used to clean air in a hospital. Air to and from different area needs to be filtered with different levels of filtration depending on the level of contamination or the cleanliness of the air which is there. There are also high efficiency particulate air filters, more commonly known as HEPA filters, and this is an efficiency standard of air filters. Filters meeting the HEPA standard mostly satisfy certain levels of efficiency. Filters may also be MERV rated. Even though in many large commercial buildings in the warm regions of India, we do not provide winter heating, but in hospitals, maintaining optimum temperatures is important and heating and cooling are both provided. So for heating, we use boilers. Boilers produce steam which gets pumped throughout the hospital and is responsible for keeping a comfortable temperature as well as for maintaining the right level of humidity so as to prevent the growth of viruses, bacteria and fungus. HVAC systems have their own independent boilers and not linked to the normal pumping system. In summers, chiller water is provided by the chillers, and in winters, boilers are used to run hot water through the pipes. For this, we can use either a 2-pipe system or a 4-pipe system. The 4-pipe system has a higher initial cost as it uses more material but achieves better results. In this, 2 pipes are used for hot supply and return of chilled water, and the other 2 are used for the supply and return of hot water. For a small hospital, for the purpose of cutting costs, 2-pipe system can be used, where the same 2 pipes are used for supply and return of chilled water in summertime and for hot water in the winters. In that case, we still have to provide a 4-pipe system for critical areas like the OTs and the critical care units. Ventilation is also a part of HVAC. So for ventilation of the non-air conditioned areas like the basement, we provide a ventilation system using a network of ducts and fans, or we can use jet fans. These are especially critical for smoke extraction during a fire, and a correctly system design is important, which is as per the codes, and it is mandatory before the fire department will give you a no objection certificate for that building. Ventilation can be done in 2 ways. The first is ducted. In a ducted system of ventilation, on one side of the building, we install shafts and fans for supply of fresh air through the ducts. On the other side, we provide shafts and fan rooms for return air through the ducts, as can be seen in the image. Both the supply and return ducts are spread throughout the area to be ventilated, sort of like this. In the example seen in the drawing, the supply ducts are being taken at the ceiling level throughout the basement. The supply ducts are then taken down along the columns, and the supply of fresh air is at a lower level. Return air is taken from a higher level. The second method is jet fans. A jet fan system is a duct-free system relying on a series of strategically placed jet fans to control and distribute air around the basement area. Main extract fans take the contaminated air out of the car park with fresh makeup air supplied from the entrance or exit ramps or through supply fans required. A CFD, which is a computational fluid dynamics simulation, is recommended to be very sure that the system is correctly designed to extract all smoke during a fire.